start with the introduction, right? The subject which you are going to learn this semester and which you are going to keep it throughout your career is engineering graphics, right? So previously it was named as engineering drawing, okay, so that many of you know of that, engineering drawing, but nowadays it is named as engineering graphics. Why? Because in few years back all engineering technical drawing will be drawn in manual. Okay. Nowadays it is not like that. Any drawing it is drawn using computers nowadays. That's why using the computer graphics, whatever design you have, you can draw it using computers. That's why the name slightly it is changed as engineering graphics. Even though engineering graphics is nothing but an engineering drawing. Right? We'll move on. The engineering graphics, if you see, it is a graphical language of engineers. So we say it is a graphical language. Something like other languages, it is also a language and any engineer should know. Right? So you know a language, why I am calling it as a language, right? So suppose I have a vertical line like this, another vertical line, this is another vertical line. If I join this two vertical lines with a slant line, what do you call this? This is N, right? Similarly, I can draw two vertical lines like this. Okay. This two vertical lines, I can join it with two horizontal lines like this. What you call now is a rectangle. Right? It is a geometry. Right? This is a letter in English. This is a geometry in engineering graphics. Right? Suppose I put a circle here, something like this. Curved oval element, okay, oval like this. It is, you know very well in English it is O, okay. So altogether you can see, it gives you a meaning, no, right. So similarly, this rectangle, if with this rectangle, the same circle if I put it, the right side or left side, a circle if I put it like this, these two geometry, this is a circle, you know, these two, rectangle and a circle all together, side by side, if I draw it like this, it will give you a meaning. What is this? A cylinder. Okay, it tells you it is a cylinder, it is a view of a cylinder, two views of a cylinder. So combining this geometry and this geometry, it gives me a meaning. That is nothing but a physical component. Okay. Nothing but a simple cylinder, right? So similar to any language, it has the geometry is combined together in engineering drawing will have a meaning. Okay, so similar to a language, it will have some grammars also. You can read this, you can write this, you can write in the sense, you can draw it. Okay, and it will have some meaning, right? It will have grammars also. Grammar in the sense, if I put a circle to the right side like this, it will have if I put a circle to the right side, it will have a meaning. If I put a circle to the left side, it will have a different meaning. That is, it is done in third angle projection, done in first angle projection. Like you have, like any other language, I can say this. Drawing, engineering drawing, what you are going to study, it is also a language. This language, all engineers should know. Okay. So throughout your career, you should remember this language. A normal person don't know about this language. Okay. What is a drawing? What in a drawing? What it tells? Okay. How to read the drawing? What it mean? What is it mean of that drawing? Okay. That's what you are going to see. I can say, broadly I can say it is a graphical language of engineers. Right. So you can have some difference from the other drawings. Okay, you know, some artists will be drawing some drawing. It will have some, it will convey some message. Okay, so similarly, there is a difference between an artistic person drawn drawing and an engineer drawn drawing, right? So an artistic drawing, it will give you the emotions. Okay, here the same artistic drawing, you can anybody can read, anybody can say it is a good drawing or it has this meaning. If it is a modern art, one person can say it conveys some meaning. So another person says it conveys another meaning. Okay, but the drawn person will say it will have a different meaning. Right? Right. So, but an engineering drawing, it is not like that. It is drawn to certain standards. So whoever reads, it will convey the same message. Right? Wherever he is, whoever reads, if he knows the drawing, engineering drawing principles and standards, the drawn drawing will be conveying a single message. Okay. So there is a difference between other drawings, engineering drawings. Then, so there are application fields in any engineering field you take. You should come across this engineering drawings. Okay, you have to come across any kind of drawing. It will be a technical drawing of sort. It can be a flow chart. It can be a programming layout. It can be a electrical wiring diagram. So, as far as mechanical engineer is concerned, any component drawing, any real life components, it will be realized only from the. It will be realized any component if you have in reality. It can be realized only if you have the drawing of that component. Right? If you have only technical drawing of that component, engineering drawing of that component, then only it can be made. Okay, the component which you have visualized, it can be made. So for a component to be realized, the very first stage is to draw a drawing for that, engineering drawing for that. Right? So as I told, it is commonly used in almost all the fields of engineering. So that's why we have it is a general subject for all engineers. Okay. In your first semester itself. You can say this is an example of a mechanical component, simple mechanical component drawing. Okay. It's a thin plate which has 4 holes. Okay. In the center I have a hole. Okay. It's just a thin plate. So the details of the dimensions of that plate is shown, and the thickness of the plates and the details are shown in a drawing. It's a simple component. You can see this. So this is another mechanical component drawing. It is heat exchanger. Okay, it is a heat exchanger. It is not actually showing all the part details. It's just showing the overall dimensions and what all the parts involved. Okay. To go in detail, you have to add sheets. You will have a separate component drawings inside you. It will be of more than 100 components. This same part, the heat exchanger will have more than 100 components. So for each component, you have to go for a separate drawing. Okay, this is an overall drawing of the component. Similar kind of drawing you have to come up. At present, you cannot read this. Once you complete this course, you have to read this drawing. Okay, what it says, what it conveys. Right. Similar kind of drawing also you should be able to draw it. Right. At least not finishing up this semester, at least end of your course. Right. So this is a building drawing, you can say, for civil engineers. This is drawn as per the drawing principles and standards. And who knows the drawing standards and details, what is, them only can read this drawing. Okay. Similarly, you can see an electrical wiring diagram. Okay, these are all not have standards, but it is drawn by a draft process, right? So you can see similar kind of electronics drawing. Okay, in electronics component, electronic elements, you will have a smaller components. Whatever kind of retention, okay, one right side of your computer plug, I think. Okay, something else. It is an electronic component. Okay, the details of that component is drawn. And this is a flowchart. Okay. Why I am saying this is a flowchart? It is not drawn as per the principle. Okay, you don't have standards to draw it. But this, as far as an programmer concerned, so he will be doing some program. It will be stored in a system. Okay, what kind of program? What is it? What it will convey? How he has programmed that? Okay, the details he can only tell it through the flowcharts. Okay, flowcharts. So the flowcharts only convey what are all the details gone into that software, that program. Right? So this can be read only by the technical persons. Right? So this is before. This is a broad, brief description about this subject what we are going to learn. Right? So the graphics, it will, the drawings which you are drawing, it will take away your idea. Okay, and that is the primary one to realize any product. Okay, you have any realistic product out. Okay, the primary thing is you have to draw the drawing from. Right, engineering drawing, and that too it should be drawn to the standards. Right. So we will get into the subject. So this is engineering graphics. The syllabus is given. Overall syllabus. What is the first thing is not the unit. It is the basics. Okay, that's what we are. I'm trying to teach. Okay, the drawing instrument, dimensioning, conventions. Okay, what are the standard conventions available and types of lines, some simple geometry constructions. You may know that constructions, okay, earlier. Then unit 1 you will have curves and orthographic projection. Okay, unit 2, projection of points, straight lines and planes. Then unit 3 you have projection of solids. Okay. Then you have unit 4, section of solids, sectioning of solids, then development of surfaces. Then unit 5, it's a pictorial projection. That's a three-dimensional view of any component. That's how to draw it in isometric view, in perspective view. Right. The textbook given in your syllabus is Engg engineering drawing. Engg. Okay, this syllabus is available with you. I think you have a instrument first. Okay. For my convenience, I have used. I'm going to deal the drawing instrument finally, because since you don't have your instruments with you, if you have your instrument, that will be better dealing with that. So now instruments will be teaching very first. Right. So for my convenience, I have arranged like this. We will get into BS conventions, this conventions, then usage of pencils, the types of lines, dimensioning and simple geometry constructions. Then we will go to use, how to use the instruments, about the drawing instruments. So what is BAS conventions? What is BAS? Bureau of Indian Standards. Right. So there are some standards available for drawing, as I told. Okay. So whatever you are going to draw it, you are going to write it in a drawing sheet. Okay. In a drawing sheet. If you have some standards, you have to obey some standards and you have to write it in the drawing sheet. Right. Anything you are going to do in a drawing sheet, you have to do it like that. Right. So we'll see basis. Base conventions. What are the conventions? There is convention for drawing sheet, which you are going to use. That drawing sheet. So the drawing sheet, if you see, starting from A0, the size, standard sizes, A0 size. So the drawing sheet, A0 size, if you know this dimension, okay, say 841 by 1189. It is in mm. is in mm, right? 841 mm by 1189 mm. The size of the drawing sheet, A0 size of the drawing sheet, it is standardized, right? So the next A1 size, if you see, if I fold this A0 size drawing sheet, okay, I will get an A1 drawing sheet. If I fold the A0 size drawing sheet, I will get an A1 drawing. Suppose I have a A0 size drawing sheet is like this. Say, this is 841, this is 1189 mm. If I fold it, what will happen? Half of this. Okay, one will be half, another will be remain. This will be, okay, so what I can do, this will be half. Okay, what is it value? 594.5. Okay, I can keep it 594. Right. And this will be remaining as such. Right. 841 mm. So what I have, some drawings I have. Real drawing I have. Okay. In this drawing you can see this size is A1 size. Okay. This is one drawing, this is a circuit drawing. Okay. So once you are able to finish this course, you should be able to read this drawing, this kind of drawings. Okay. So in your career, you will be definitely come across this kind of drawings. Okay. So this is the size. It is A1 size. Okay. A1 size. So the length is nothing but this 841. This is 594. Right. This height. So this is A1 size. You can keep it like this. Right. Now if I fold it, this drawing sheet, if I fold it, it will give me A2 drawing sheet. Now this is this A2 size drawing sheet. So this is A2 size drawing sheet. 841. So 841, half of 841 will be 420 by 594. Right. Still, if I fold it, I will have A3 drawing sheet. The A3 drawing sheet, this is 594 by 2. That is how much? Yes. 2? 97. 420. Right. So the A3 drawing sheet, this is the size you are going to use it in this semester, right? A3 drawing sheet. So A3 drawing sheet is one you are going to use. Suppose I fold it again, I will get an A4 size. So A4 size drawing sheet is 210 by 297. So I have some of the real drawings. If you want, you can see. So this is another drawing. Okay. Drawing for, I think it is a plant room. Okay. Plant room layout. Okay. Similarly, I have building drawing. I had a component drawing. Okay. I'm not able to get it. Okay. So as a mechanical engineer, definitely we will come across component drawings, many component drawings. Like this is a building drawing. These are all printouts. So it is drawn in computers and it is taken printouts. But previously, a few years back, we have to draw it. This is, we'll have a big drafters and boards. The draft portion will be there. We will be drawing that. So this is about the drawing sheet. So the standard in drawing sheet. Then we have drawing layout. Okay, in your A3 drawing sheet, what you are going to use it. Okay, there is a standard you have to follow it. So you see here, just to remember this A0 size. 841 cross 11890. Okay. From that we can get the other sizes. Right. Then drawing layout. As for drawing layout, suppose I have my drawing sheet. See, my drawing sheet is this board. Okay, this board is, so consider this board is my A3 drawing sheet. Okay. So in this, the drawing layout, how you have to draw it? The drawing layout would be, you have to leave, you can see the drawing layout here. It's nothing but the border. Okay. So in the drawing, you have to draw border lines. Okay. That is nothing but layout. It is layout. So this layout, in your drawing sheet, how you have to draw it? You leave 20 mm gap from the left side. Okay. You have 20 mm gap from the left side. Draw the line. From the left side, you have to leave 20 mm gap. So remember that this gap is 20 mm. This gap is 20 mm. Right, in your A3 drawing sheet. Then all other three sides you have to leave 10 mm gap. Okay. Just you can draw it in your notebook. Simple. All other sides you have to leave 10 mm gap. See, this gap is 10 mm. This gap is 10 mm. Okay. This gap is 10 mm. Okay, why I am using a color chart? It should be a dark one. Okay, in your drawing sheet, A3 drawing sheet, the layout should be a dark one. It should be drawn in your dark pencil. So what we will be going to use, we are going to see about pencils. The dark pencil you are going to use is a HB pencil, right? So using HB pencil, you can draw this layout in your drawing sheet. Okay, you should have 20 mm gap. In the left side, all other three sides you should have 10 mm gap. So any drawing sheet, if you see, it will be used in one side only. Okay, actual drawings, it will be drawn in one side. The rear side, it will be empty. So, but for our convenience, okay, you will be having more exercises to do. Okay. So in the same drawing sheet, you can use in the reverse side also. So if you are going to use the reverse side, so in which portion you will have the 20 mm gap? Okay, the right side or left side? Right side you should have the, so if I turn this page, okay, this 20 mm goes to the right side. So to the right side you should have the 20 mm gap. Okay, why this 20 mm gap I am leaving to the left side? What is the significance? What is the convenience? Huh? Just you can staple it. Okay. To file it. Okay. You can file your drawings. Okay. If I have 20 mm gap, I can file it the left side. Okay. You file your drawings. Okay. You have the 20 mm gap. Go to the next one, title block. Okay. Any drawing you can see, right bottom corner, the details of the drawing will be given. The details of the drawing will be given. That is nothing but the title block. Okay. So the title block for different companies, they will have, each company they will have their own title block. Okay. So in our class we will have a standard title block. Okay. That you should have in your all your drawings sheets. Okay. So the title block occupies the space of right bottom corner. Okay. We will have the size of the height of the title block is 50, say 50 mm height and the length of the title block, which you are going to draw it on the right bottom corner, it will have a 150 mm length. Right. This is the title block. The title block height, this is 50. This is 150. The vertical line length is 50. This is 150. You use it 150 mm, all in mm. Now this title block I am going to split it. Okay. To represent my details. Okay. Of drawing. So this title block I can split it like this. Okay, the first segment, since it is 50 mm and height, so I am going to split it as 10 mm. I am going to the first block. Okay, this is 10 mm. So each one I am going to have it for a 10 mm height. Okay, the second one, similarly from the bottom, I am going to have another 10. You see. With this you can draw it in your notebook. Okay, from the bottom I am going to have another 10 mm box. Right. Then this in between I have 30 mm and the length of 150 mm. Okay, this one I am going to split it into exactly two halves. Say two halves in the sense 75. Okay, 75 each. Okay, then this left 30 by 75 box, I can split it into 3 more separate 10 mm box. Okay. So 3 more separate 10 mm box, I can split it. So all are 10 mm. The box heights are 10 mm. Okay. Even though it looks some deviation, okay, it is 10 mm height. This is the portion, okay, a big gap you have, there you are going to show the symbol of the projection, okay, the symbol of the projection, either in which angle projection you have used, okay, that you will be showing in this box, okay. So what are the details we are going to write in this title block, you will see, right. So this title block as such, what I have drawn here, it should be in HB pencil, it should be in dark, okay, you have to draw it in HB pencil, the darkest pencil you have is the HB, right, so that using that you can draw the layout, you can draw the title block like this. Now inside to this, I am going to write the first height, I have 10 mm, I can have a 5 mm, for a 5 mm height, I can write the details of the drawing, okay, name of the drawing, okay, whichever topic you are drawing, okay, in your units, or whichever topic you are drawing in the drawing sheet, okay, that topic you can write, okay, the name of the drawing. So to write the name, you have to draw 2 parallel lines, that is for a height of 5 mm, okay, for which the parallel lines which you are going to draw is just to write your letters, okay, exactly in a straight manner, okay. So it should not be visible. So I have to draw a 5 mm parallel line inside. So why I am using white line? It is going to be a very thin light line, okay, this is going to be a very thin light line, so you have to use a pencil which is having a hardness, less hardness value, okay, that is 2H pencil you have to use. You are going to use, so far you have used HB pencil, so this is the lightest one, so you have to use a 2H pencil, okay, so to draw any construction lines, okay, any parallel lines which you are drawing for writing, okay, that should be drawn in 2H pencil. This should be drawn using your drafter, okay, you will be going to have a drafter in instruments, you will see. Using drafter you have to draw 2 parallel lines. it is visible for you. Now in your drawing sheet, this parallel line should not be visible. Okay, if I am coming and seeing your drawing sheet, it should not be visible. Just whatever matter you are writing in that two parallel line, that alone should be visible. Right, it is just for the straightness of writing, I am drawing two parallel lines. Right. So here you can write the name of the drawing, not your name, otherwise you can write topic. Which you are going to write. Okay, inside you have to write. For writing letters, we are going to see the standards. That. Then similarly, next box you can draw. Again, similarly, you can draw parallel line for 5 mm height. Okay, the box height is 10 mm. So inside, in the middle, exactly, you need not measure it. Okay, always exactly in the middle, in the sense 2.5 in the top, 2.5 in the bottom. In the middle, you should have a 5 mm, two parallel lines. So here you can draw two parallel lines. You can write something. Similarly, in all the boxes, you can draw two parallel lines. Okay, which should not be visible. It should not be visible. The parallel line should not be visible. Similarly, in the last one, you can draw two parallel lines. Right. So what? I can write it here. Here, you can write your name. So as for, you can write your name. Right. Then in this next box you can write your roll number or register number. You have register number. In the next box you can have your section. Okay, branch and section. Right. Branch. The last one, you can write all dimensions are in mm. Okay. So whatever you are going to draw it inside the drawing, the dimensions you will be specifying. The drawing dimensions you will be specifying. Okay. In that, the values, nearby the values, you need not specify the unit. Okay. So that unit I can write it here. Okay. Whatever drawn, so whatever dimensions shown in the drawing, it will be in mm. Okay. That. As a common one, I can write it in a title block itself. Okay. So all dimensions, all in mm. Can you write it in capital letter? It should be written in small letters, right? The it should be written in small letter. Right. So now this is the title block what you are going to draw it in your drawing sheets. Okay. Do you have any clarification in this? It is very clear now. Title block is 50 by 150, right? And it will have a 10 mm box inside. Okay. So here right side you will have a separation. This is a space used for showing the symbol of the drawing. Okay. Any drawing you can see the symbol. It is projection of symbol will be there. Okay. That you have to draw it here. Okay. I will come to that. Then whatever you are writing inside. So I have written in white color. It is not light one. So whatever matter text you are writing, it should be a dark one. Whether you can use your HB pencil or a next grade pencil, that is H pencil, you can use it. Okay. Either HB pencil you can use it or H pencil. So what color I have to use it? So you can go for a HB pencil or H pencil. You can use darkly. You have to print your letters in your title block, right? darkly you have to print your letter symbol. So you should not overwrite like this. What I am doing, you should not overwrite. So for writing, you should have some practice. Right. Similarly, the letters whatever you are writing, you should use HB pencils, right? Or H pencil. The next dark pencil is H pencil. Okay. So whatever thing you are going to write inside the drawing sheet, okay, that also should have a height of 5 mm. Because we have only A3 drawing sheet. So whatever text you are writing inside the drawing sheet should have a height of 5 mm. Right? Keep a height of 5 mm. Then we do title block. Okay. So if you want, you can note, you can draw the symbol also. So mostly we are going to use the first angle projection. So the first angle projection symbol will be like this. How we have got that symbol, you will see in later classes, right? So the symbol will be like this. So it is just a frustum of a cone, okay, shown in 2 views. Okay, frustum of a cone shown in 2 views. As for first angle projection concerned, the frustum of the cone, you can say the frustum of a cone in the sense the cone will be half cut cone. I have a cone like this. So I will have a frustum of a cone. If I cut a cone parallel to its base, I will get a frustum of a cone. Right. So this cone, how it is shown. So actually this cone is kept like this, seen like this. This frustum of a cone is seen like this. If I see this cone, so what will be the view of this cone, front view of this cone? That we will be drawing it. The smaller size of the base will be drawn first. Okay, the bigger size you can for your convenience, for any size you can draw it. This will be the front view of this frustum of a cone. Okay, starting from a smaller base, you can go for the bigger base. Okay, so this is the front view of the frustum of the cone. So the side view of the cone, I can draw it. So in the side view, if I look at from this side, what I can see? 2 circles I can see. This frustum of a cone, if I look at from this side, I can see 2 circles. Okay, these 2 circles will be shown. So conveniently you have to use your compass and to draw these circles. Okay, you should not draw it in freehand. Right. So this is the 2 circle. It is shown. Right, like this. This is the symbol of the first angle projection. So any side view, if I look at any side views, if I look at from the left side, what I am seeing, it will be drawn on the right side. As per the first angle projection, it will be drawn to the other side. Okay, we'll see in detail, okay, about that projection. So this is the symbol of the first angle projection. So if the same 2 visible circles, if I draw it to the left side, if it is drawn to the left side, it will be a third angle projection. Okay, if the symbol is changing, so whatever drawing you are representing inside the drawing sheet, it is drawn as per the third angle projection. Now, it is the symbol of first angle projection. So whatever drawing you are drawing inside, it will be drawn to the first angle projection principle. Right? So, we will come to that. Folding of drawing sheets. Okay. So for us, it is not a problem. So we have only A3 drawing sheet. How we can easily fold it? To find it. How we can easily fold the A3 drawing sheet? So this is the A3 drawing sheet I have. How I can conveniently fold it? Yeah. Just I can fold it like this to match the left margin, left layout. What you can do, so after folding, the title block and the drawing detail should be visibly come to the top of the your folding. Okay, this is the title block I have for this company. Okay, these details should be visible in your file. While you are running your file, these details should be visible on the top. So, in that manner it will be folded. So, and this detail, I can say this detail, I can fold it like this. So, this whole thing, this is the detail, title block detail, it matches with the left, okay, layout line. Okay, then if I want to fold it like this and if I punch it and file it in my file, what will happen? I cannot open the drawing. It will be intact. Okay, what I can do, whichever portion I am folding back, okay, in that I can have a folding like this. Now I can fold it conveniently like this. Right. So now this is the only region I can punch it and I can file it. In a file, I can, with the file itself, I can open it and I can open the drawing, I can read the drawing. Okay. So lettering, so whatever you are going to write inside the drawing sheet or in a title block, okay. For writing, you have to do anywhere, any writing you are doing in a drawing sheet, you have to draw two parallel lines, and I told you maintain a 5 mm height. Because if you have a 10 mm height, it means you are not able to write neatly inside to that 10 mm height. Okay, you keep 5 mm height. Okay. Keep 5 mm height. Two parallel lines. So this is a white line. You have to use which pencil? 2H pencil. 2H pencil is the lightest pencil used for construction purposes. Okay. It is to draw light lines. Okay. It should not be visible in your drawing sheet again and again. Now the A, letter A, as usual you can write. The difference alone, you say the capital letter A, you can make note of this. B, as usual, you can write it. Right. C, as usual, you can write it. D. So normally D we will be writing. So anything you are writing in capital letters, you will be writing like this. Right. The extension of this portion should not be there in your drawing lettering. Right. So it should be, D should be like this, right? This is the wrong one. E, as usual you can write it E, but you should not use E. You should not write it. This is the wrong one. Just it should end sharply. Okay. So any stylish manner you should not write. Okay. So then F, as usual you should write F. We make note of this F. G. G normally we will be writing in capital letters, we will be writing G like this. So this is the wrong one. So in our drawing, so we have to write the G and it should end like this. Right. H, as usual, you can write it. I, normally you will write I like this. Right. So this is the wrong one. I should be just a vertical line. It is not 1. So 1, how you have to write it, you will see. This is I. J, as usual, J, without the head. If this is a wrong one, what I am writing on the top, it is a wrong one. So normally you will be using. Okay, that is the difference you have while you are writing in drawing. J. K, as usual, L, M as usual, N, O. There is a difference in O and 0. So normally the O, you have to write it right, something like a digital O, you have to write it. It will be a curve, not digitally. It is a short chamfer. It is a curve one. Okay, so O should be like this. P, as usual, you can write it. Q, you have to put O. Q normally we will be writing. If this is a wrong one, you will be drawing a over circle, then you will be representing Q. So Q will be, you have to show O. Q, just a slant line like this. Q. Just you remember the difference alone, right? R. The R. As usual, you can show it. Yes. As usual. T. U. V. As usual, V you have to represent V. W. X. Y. Z. So the difference alone, you remember it. Okay. Whatever you are going to write in your drawing sheet, you should follow that. The standard is, I think it's a Gothic one in your Word. The standard font is Gothic, I think. Then, in small letters, to write in small letters the same thing, they write. You have to put 4 lines. Convenient height. Okay, the overall, this will be 5 mm. Over that you can have 2.5, 2.5. Okay, overall 10 mm you can have it. Right? So, A, anything you are writing, it should be in the middle. Middle 2 line. This is A. Then, B. C, you have to write it in the middle 2 lines. C. D. E. F. So normally F will be writing like this. Okay. So F will be crisply ending with this. G. H, I with a dot, J with a dot, K, L, small line there, M, N, G and Q, you have a difference, right? R, just a line, vertical line, and you have to write it. S, T, U, V, W, write as usual how you are writing, and the difference you see, you can able to remember. So whatever you are writing during the writing practice, okay, you write these letters in your notebook neatly, you write, you draw it, parallel lines in pencil, right? And use HB pens to write it neatly, you print it and bring it to the next class. Okay, I will see that. Because I am not going to give the lettering practice separately, right? This is a practice you have to do it. You write it in your notebook separately, next class you bring it, right? So over that, you try to write as usual how you will write. And you see this, so you can remember the difference. Okay. As usual, small letters how you will write, capital letters how you will write. So what is the difference? Just you see that you write the numbers for 5 mm height. Okay, for parallel lines, the number will be 0. Starting from 0, 0 will be something like that, oval. 1, you can put. This is 0, this is not O. So there is a difference between O and 0. Right? Then 1, this is not, this is as such it is a I. As such it is capital I. So 1, just need a slant line in the top. So this is 1. So 2, as usual you can write 2, 3, as usual, 4, 5, 6, as usual you can write 7, 8, 9, inverted 6. Normally we will be writing this 6, 9 and all, 6, 9 and all will be writing like this, okay. Should not write like this, it should be inverted 6. So there is a difference in O and 1. Right. So this is about the standard lettering. Normally the lettering, if you see in books, you can see there will be drawing a box. Okay. There will be inside box, they will be constructing, they will have some lines, vertical, horizontal lines. In that they will be written the letters. So that is a very old procedure. So nowadays in computers you have a standard font, right? Usage of pencils. Next one. So as I told, so far I have mentioned only 3 pencils. What are they? HB. HB is a darkest one which you are going to use it, right? In your drawing, the HB is the darkest one you are going to use it, right? So that is used for dark outlines, okay, layout, title block you will be using, and lettering. Okay, you will be using the HB pencil. Then you have 2 H pencil, H pencil. The next highest grade dark pencil is H. Okay, that is used for drawing outlines. Okay, it is a little bit dark one, not like HB pencil, right? So the other one you are going to use it 2H pencil. Okay, the 2H pencil is nothing but a light one. Okay, it harnesses 2 hardness, so it is a light one which you are going to use it. Okay, that is used for drawing construction lines. Okay, anything you are going to construct, any drawing you will be doing some construction works in during your drawing. Okay, that construction lines and construction elements will be drawn in 2H pencil. It should be very light. It should not be visible. It should not be prominent in your drawing sheet. Right. So you can see clearly 2H. You can use it for thin construction line. H, it is a medium dark line. Right. Then HB is dark to draw dark line. Okay, these 3 pencils you should have always with you. Right. So either in a microtip one. So in microtip if you should have a proper grade inside. You should have proper grade. Right. So otherwise you should have a proper pencil. The pencil you have to use it always, it should be sharp. Okay. You should have a sharpener with you. whenever it is blunt, right, you have to use a sharp, right. Pencils, you see, you have to properly use the pencil. That is the one. The same H pencil, I can give the impression of HP pencil. Okay, if I give more force in H pencil, it will be dark, still more dark, right? So you have to properly, if you are going to use 2H pencil, so 2H pencil you have to lightly you have to use it. So the pressure you are giving while drawing the line, you have to use lightly, you have to give a very less pressure while using a 2H pencil. Otherwise it will look like a H pencil, right? Whatever line you are drawing, it will be like a H pencil, right? So proper usage of pencil also you have to use. You have to use a sufficient pressure for sufficient proper pencil, right? This is about pencil. Then you see the types of lines. These are all the standard lines available which you are going to draw it in your engineering drawing. Okay. There are certain types of lines available. So the first line, you can draw a table like this. You can draw a table like this. What is the name of the line and what is for it is used, right? Where it is used. What is the grade pencil you have to use it, right? Then how it will look like, right? The line will be a continuous thick line. The line name is continuous thick line. So you can see where it is used. Actually, the continuous thick line it is used to show in your drawing the visible outlines. You can see the step shaft. It is hollow. Okay, it is a hollow one. I have a shaft. Okay. So this shaft in my drawing, as such, if I look it in this direction, I can see a view of this. I can draw the view, right, using any projection. So if I draw this, the visible outline of that view, it will be drawn in the continuous thick line. Right, you see here the front view, how it will be this shaft, the front view will be like this. This is a visible one. This is a visible outline I can see. The front view of the shaft, it will be look like this. Right? Is it clear? So if I look this shaft like this, you forget about this hole. What it is having? Okay, forget about this hole. It is just a shaft. It is a hollow shaft. So whatever depth it is hollow, it is not visible. Right? It is a hollow shaft. So if I look at in the orientation, I can see the front view like this. So whatever the visible edges I can able to see, that is drawn in the continuous thick line. Okay. Similarly, the same shaft, if I look at to the right side, okay. If I look at to the right side, I can draw it as this. It will be seen as two circles. So this is a circle. While looking on the right side, I can see a circle. Right. First I can see a circle. Right. Then this is another circle I can see, a bigger circle. So the bigger circle like this. Okay. So the hollow details are not given here. Okay, I will come to that later. So this is a visible one. I know if I look at this shaft on the right side, so the right side view I can see two circles. So one is this circular diameter I can see. The another one is this bigger circular diameter I can see. This is so whatever you are drawing in this view, this is a visible edge. I can see it in a view. Right. So that is drawn by continuous thick line, continuous thin line. So continuous thin line, you can see where it is used. It is used in dimensioning, ladder line, and it is used extension line, construction lines, and hatching lines. Right? It is drawn using the pencil. It is a thin line. You have to go for a 2H pencil, thin pencil, which is a 2H pencil. Right? So you can go for a 2H pencil. So whatever the construction line, right? So in your lettering, the construction line you have drawn, okay, parallel lines, that is drawn in 2H pencil, right? So it is a continuous thin line. So dimensioning, so suppose I am dimensioning this component, okay, this view, so I will have the dimensions, I will be incorporating the dimensions, okay, few dimensions I will incorporate. So this is called an extension line. What I have drawn it here, this is called the extension line, right, or a dimension. So whatever I am drawing horizontally, parallel to the entity which you are dimensioning, so that is called dimension line. That is also drawn in 2H pencil, right? Then it is dimension as such with arrowheads. So these lines, dimension line, extension line, we will come to the hatching line and all, okay, later. The hatching lines. So these are all drawn using 2H pencil, that is called a thin line, continuous thin line, right? So you will have some value for this. This is 40, this is 10, this is 70. Right. So I haven't mentioned the unit in the dimension value. Why? What unit is this? This is in mm. Okay, it is mentioned here. It is all dimensions in mm. Okay, whatever dimension value you are presenting in the drawing sheet, it is without units. Okay, the overall unit will be shown in the diagram block. Right. So this is the second kind of line. Next, like it is short dashes or hidden lines. You can write hidden line. You can write it as hidden line. Is used for invisible edges. To show the invisible edges, we will be using a hidden line. It is a small dash. Okay, you should not leave more gap. It is a small dash line. You can see it has a small gap in between the small lines. Right? So that is called hidden lines. So it is normally used in representing invisible edges. You can see here. As I told, it is a hollow shaft. As I told, it is a hollow shaft. So, what distance it is hollow, it is not clearly shown. Okay, what I am telling, it is hollow up to this region, or it is hollow up to this shaft region, this portion. Okay, or it is hollow up to some distance. So, in my drawing view, I can show that as a dash line. Okay, as a hidden detail. So in this view, can I show hollow portion? So I can show it. If I want to show the hidden detail, okay, I have to show it with the hidden line. I have to show it with the hidden line. In this front view, there is a hollow portion here, all through it is going to some distance. Okay, I can represent it as a dotted line. See, it is a hidden line. It is going through. What pencil we are using? Sharp pencil. So it is going to some distance. So up to this distance, it is hollow throughout. Is it clear? So now you can clearly see in the view. This is a view of this shaft. Inside there is a hollow portion. Okay, that hollow portion is shown in the view itself. It is in a dotted line. Okay, so that is the dotted line. So the same hollow thing, I can see it in this view also. How it will be? It will be a like this cone circle. How it will be a cone? It is just a hollow circle. Okay, just a cavity, circular cavity inside. So in the side view, I can see that also as a circle, right? A dotted circle. So exactly at this location, I can see a dotted circle in the side view. Right. So this is a representation of a dotted line in your drawing. Okay, it is normally used for showing the hidden details. Right. It is a long chain line. It is a long chain line. You can see the long chain line, there is a difference between a hidden line and line. So you have to carefully represent it. So where it is used, center lines, to show the center line it is used, it is drawn in 2H pencil, right? It is a light line, representation is like this. You have to draw a lengthier line, okay, approximately 15 mm. Then you have to draw a small line, leaving some gap. Oh, then 15 mm approximately, small gap, small line. Then a lengthier line, small line. Okay, that is the representation of a center line. So any cylindrical object you have, I have to represent it with the center line. Okay, any cylindrical object you have, I have to represent it with the center line. So you can see this is a cylindrical one, this is a cylindrical shaft. So here I can show a center line. So the center line will be length here, 15 mm line and a short line and a long line, short line, long line, short line, long line, short line. Right. This is a center line. Similarly, for a circle, I can show the center line, long line, short line, long line, short line. Match with this. So clear? For representing the center lines, for a cylinder, normally center lines will be representing for a cylindrical objects. Right? So that will be shown as a long chain line. It is a thin line, it is drawn in 2H pencil. It will be like this. On to the next line. A long chain, thick at the ends and thin elsewhere. Right? So similar to this is typically it is similar to the center line. Typically it is similar to the center line. Right? So what is the difference between, so what it tells, it is thick at ends and thin elsewhere. So the same center line you have to draw it. The normal center line it is thin, all over it is thin. The last two ends you have to thicken it. The two ends you have to thicken it. That is used, normally it is used to represent the cutting planes. Normally it is used to represent the cutting planes. So cutting plane in the sense, you have inner details. In your component, if you have complex inner details, what we will be doing, we will be using a cutting plane, right? We will be using a cutting plane, that an imaginary cutting plane. It cuts where you want to show the inner details. It cut that solid, okay, and the cut section it will be shown separately. Okay, in a view or it will be shown separately. Okay, to represent a cutting plane where it cuts the solid, to see the inner details, you will be representing a line with this line. Okay, this is called a cutting plane line. Section line, it is a section line or cutting plane line. So the name is long chain, right? Thick at ends and thin elsewhere, right? So suppose I want to represent a cutting plane here. You see, suppose I am sectioning this portion. I am sectioning this shaft here. You see, I am sectioning this shaft. I am representing a cutting plane. This is a portion. See, this is a portion. I am going to introduce an imaginary cutting plane which cuts the solid. Okay, which cuts the solid. I am removing the portion, one half of the portion. I am going to look at the solid, how it is going to look in a view. Okay, so the representation of the cutting plane. The representation of a cutting plane, I have to represent it like this. The representation, if you see, there is a continuous line, thin line, and continuous thin line. Right. Then it should be thick at the ends. So thick at the ends means it should be dark. I can thicken this at the ends. So I can thicken like this. Okay, this is the representation of a cutting plane. It means I am introducing a cutting plane here in this object and to cut this solid, and I am removing a portion of this solid. So which portion I am removing, actually I will represent it with an arrowhead. So you can see, suppose I am showing an arrowhead in a cutting plane like this. What it means, I am introducing a cutting plane, it cuts the solid and I am removing the right portion, and I am looking at the object in this manner to show the left side view. Okay, while I am looking at the object, wherever the cutting plane intersects the material, wherever the cutting plane intersects the material, where it intersects the material here, it doesn't intersect the hollow portion. There is no material here in this portion. Okay, there is material involved here, material involved here. If I introduce a cutting plane, the cutting plane cuts the material here. So what is that portion here? This and this. Right. So this is the only portion. This is a region. The cutting plane cuts the material. So that cut portion, I can show it as a hatched line. Okay, wherever the cutting plane intersects the material, okay, cuts the material, that portion is shown as a hatched line. So this is a sectioned portion. So now the dotted line goes off because I am going to show the section line. So here I can introduce a hatched line. So about hatching, we'll see. So this is hatching. So already hatching line is what kind of line? See, hatching line is what kind of? It's a thin one. Okay, second one, it is a thin one. Okay, hatching line. A continuous thin one, it should be in 2H pencil. So the section portion is shown here. So the sectioning of solid we are going to see in a separate chapter. Right? This is about lines. Then we have one more line, continuous with zigzag line. Continuous with zigzag line, normally you are not going to use in your in any engineering drawing. You can see that. Okay, if the object is very length of the same kind, the shaft, if you see, instead of 70 mm, if you see it is 700 mm or 700 mm length. So I need not show, it will go out of my drawing sheet to this scale what I am drawing. So what I can do it, I can draw it up to some portion and I can terminate it with a zigzag line like this and I can close it. But the dimension I can show it to 700. So there is a zigzag line. Long break line. So I think you are clear with the lines. Do you have any doubt in lines, types of lines? Okay. Okay, how to represent it? What is the pencil you have to use it? Right? It's clear, I think. Shaft. You see the shaft drawing here. It is some shaft. Okay, you have so many details in the shaft. Right? See here, I have a thread in this end. Okay, I have a step here. Here I have another step portion. Here I have so many grooves here. Then there I have thread. This look like simple to produce this. Okay. To realize this component, you need to have a component drawing of this one. Okay, the component drawing is, see the component drawing, it will be like this. Okay, something like this. The component drawing will be, let's see, this is a simple shaft. It looks like a simple shaft. So to produce this shaft, so whatever details involved in this, so all the production details, okay, whoever a machinist, how he has to produce this, he will be having only the drawing. So from the drawing only he have to read everything. So according to that he has to realize that shaft. Okay, you can see in this, it will have the tolerances. Okay, apart from this kind, exactly outer dimensions, it will have the tolerances involved. Okay, that tolerances he has to incorporate in his machine. Okay, within that tolerance he has to produce that component. Okay, that details is involved in this drawing. Similarly, you can see the cutting plane. Okay, the cutting plane cuts here and he is looking at it in a third angle position, right? He is looking at the shaft and it is shown in the front view. Okay. The third angle projection one. Front view, you can see the hatching line. All over the whole shaft is cut into two halves. So the cutting plane, it cuts the material through the shaft. So the whole shaft is hatched. This is a sectional view of the shaft. Right. So I want to see the details of this particular area because it is too small in my drawing. It contains very smaller details. Okay. There I am not able to represent the dimensions and the details. So what I am doing in my drawing, just I am encircling that and I am enlarging it, I am showing in a separate view. Which region you are interested, that you can show it as a separate view. In that you can conveniently show your details, okay, production design details. Right. So as a broad one, engineering drawing you can say, so it is a production drawing, okay, the drawing which has all the details of the component to be produced. Okay. So it is a very primary one for a component to be realized. Okay. So first you have to imagine a design, okay, what kind of component you are going to produce. That imagination you cannot tell to, okay, how to draw it. So whatever things involved to produce that component, so all the details will be involved in this drawing. So that is given to the production person. He will reading this drawing according to the details in the drawing, okay, engineering drawing, technical drawing, he will be producing that. So I can say broader sense, I can say it is a legal document. So any building you can say, any building drawing you are producing, it is legalized. Okay, anything you are varying, it cannot be varied. Okay, and whatever you have drawn, it will be read by everyone in a same manner. Okay, it is not like an artistic drawing.